Suppose n is a normal subgroup of a group G. Which one of the following is true? Before solving this problem, first we recall some facts related to this problem. Suppose G is a group and n is its normal subgroup. Then we can define quotient group or factor group. Quotient group and factor group used to partition the group into a smaller size, and we can investigate the smaller part easily rather than larger one. If group is cyclic, then its quotient group is cyclic. If group is abelian, then quotient group is also abelian. Cyclic group implies commutativity. So cyclic group always commutative group. If G is cyclic group, then G over N is an abelian group. Option C is true. Now come to the option A. If G is an infinite group, then G over N, normally we read as quotient group of G by N, is an infinite group. This is not true, means false statement. How? As Z is infinite group and NZ is normal group of Z, and this is isomorphic to Zn, means quotient group is not infinite. Group is infinite but quotient group is not infinite. Quotient group is finite. That's why this statement is wrong. You can find examples to discard other options, but right key is option C.